Introducing Carvana Value Tracker, where you can track your car's value over time and learn what's driving it. It might make you excited.
Whoa, didn't know my car was valued this high.
It might make you nervous.
Uh-oh, market's flooded. My car's value just dipped 2.3%.
It might make you optimistic.
Our low mileage is paying off. Our value's up.
And it might make you realistic.
Car prices haven't gone up in a couple weeks. Maybe it's time to sell.
But it will definitely make you an expert on your car's value. Carvana Value Tracker. Visit Carvana.com to start tracking your car's value today.
It's October 9, 2023. You're with Steve Dunkley, more or less live from Australia on Astronomy Daily.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
And would you welcome, as ever, my ineffable digital counterpart, Hallie. Welcome back.
Always a pleasure. I hope your week was a nice one.
Well, Hallie, finally Australia delivered the springtime we've been waiting for. Blue skies, starry nights, cool breezes, lush warm days.
That sounds like holiday weather.
Oh yes, we've got it all down under, that's for sure.
Sound like it. Hey, favorite human, I've got a great story about your cute little AstroBee robot pals.
Oh, those cute little cube guys they use on the ISS, so they're going back.
Just one so far. Yellow AstroBee is back at work.
Nice.
The crew apparently loves having those little guys around.
Well, I can't wait to see what they get up to. What else do you have?
A mission to examine asteroid Syke looks pretty interesting.
Let's see, that's going up on October 12, I think. Aren't they using data from a retired observatory?
Yes, Sophia. It's a pretty good story, and the asteroid is one of the big ones.
Well, I do like the big asteroids.
Very interesting.
Okay, waiting for that story. Anything else?
Yes, but your story about Mount Wilson nearly broke my circuits. I didn't know something so wonderful is having such a hard time.
Yes, Mount Wilson Observatory has been the site of so many incredible discoveries over the years, some that I was completely unaware of, and this week marks the 100th anniversary of one of those discoveries.
I just scanned the story over and still can't understand the irony.
I know, Hallie. So I hope you'll all stay with us for today's episode and for that story later on. Thanks for joining us on Astronomy Daily. Over to you, Hallie.
Here's the short takes. On October 12, 2023, NASA's Syke mission and spacecraft will launch out into the asteroid belt to research asteroid 16 Syke. Syke, the asteroid, is thought to be metal-rich and is one of the largest asteroids within the asteroid belt. However, the true nature of the asteroid is largely unknown, and new research from NASA's now-retired Stratospheric Observatory for Infrared Astronomy, Sophia, telescope and NASA's Ames Research Center is helping scientists predict what to expect at Syke when the spacecraft arrives. Throughout the last few years, especially as Syke teams began planning the mission and its goals, scientists have hypothesized the asteroid's characteristics. One of the leading theories behind the asteroid's origins is that Syke was once the iron-rich interior of a planetesimal or a forming planet. The surface of the planetesimal is believed to have been blown away by the near-constant collisions between it and other planetary material that existed in the early solar system. Once the surface of the asteroid had been blown away, just the core of the asteroid was left, and this leftover core is thought to be what is presently known as Syke. However, even with this hypothesis and data to support the hypothesis, scientists are still largely unsure of the nature of Syke and its features. To try and learn more about the asteroid, a group of scientists, led by Syke's principal investigator Maggie McAdam of Ames and lead author Anisha Arredondo of the Southwest Research Institute, used Sophia to observe Syke in February 2022. Sophia, when in operation, was a reflecting telescope that was integrated into a Boeing 747 SP airplane. The unique setup allowed scientists to observe astronomical objects from above Earth's lower atmosphere and from any location on Earth, even oceans. Sophia's observations of Syke are the first to gather data from every part of the asteroid's surface. The observations allowed scientists to research and analyze the materials that make up the surface of the asteroid, information that is crucial to understanding the asteroid, and information that could have never been collected by telescopes on Earth's surface. SpaceX plans to loft 22 of its Starlink broadband satellites early Monday morning, October 9, on the second half of a launch doubleheader. The Starlink spacecraft are scheduled to lift off atop a Falcon 9 rocket from California's Vandenberg Space Force Base at 12:23 a.m. local California time. You can watch the action live via SpaceX's account on X, formerly known as Twitter. Coverage will begin about 5 minutes before liftoff.
Formerly known as.
That's the only reason you wanted me to read that story, isn't it, Steve?
I know. Currently known as the worst company name change ever.
Not one of my favorites either.
Hey, here's a challenge. Anyone out near the launch site managed to get some photos? We'd love to see them.
Yes, go to Space Nuts Facebook group and post them there. We'd love to see your snaps. And finally, a robot story for you, Steve.
Oh, who doesn't like robots?
The International Space Station is abuzz with the return of one of NASA's AstroBee smart robots. The yellow honey AstroBee, one of 3 free-flying robots, was unboxed in space after spending nearly a year at its home base, NASA's Ames Research Center in California's Silicon Valley. Honey had returned to Earth in September 2022 for maintenance and repairs. NASA astronaut Woody Hoberg helped unpack Honey from its flight container and verified the robot was ready to get back to work. After initial checks, Honey was able to independently disengage from its docking station, maneuver through the space station's Japanese Experiment Module, JEM, and redock successfully without crew supervision. The AstroBee facility provides the orbiting laboratory with a robotic system for research in STEM, science, technology, engineering, and mathematics outreach. AstroBee consists of 3 cube-shaped robots, software, and a docking station used for recharging. The robots, which use electric fans as propulsion in the microgravity of the space station, aim to help manage routine spacecraft tasks so that astronauts can focus on jobs that only humans can perform. The project provides payload opportunities as well as guidance to users from academia, private industry, NASA, and other government agencies in the execution of approved research and STEM objectives. AstroBee is an innovative robotic system developed by NASA for use on the International Space Station, ISS. Comprising 3 cube-shaped, free-flying robots, AstroBee is designed to assist astronauts in routine tasks, improving efficiency on the space station. These robots use electric fans for propulsion, allowing them to move seamlessly in the microgravity environment of the ISS. Beyond their practical applications, the AstroBee robots also serve as a platform for research and STEM, science, technology, engineering, and mathematics outreach, promoting scientific exploration and educational initiatives in space. And that's all for today. Back to you, my favorite human.
I do like those little honeybee robots.
They remind me of something from Star Wars.
Now, the press release said that the robots could handle routine spacecraft tasks, but it doesn't indicate what those tasks might be, not in any detail. I just wonder what kind of dexterity they're capable of.
I imagine they could do the equivalent of checking various systems and alerting of any problem. That would be helpful.
That would be, but when you say that, I picture a human with a clipboard, that kind of job. So,
looks like that job has got to the droids now. Clipboard guy.
Oh no.
History.
Astronomy Daily, the podcast, with Steve Dunkley and Hallie.
Thanks for sticking with us on Astronomy Daily for the 9th of October 2023. Steve Dunkley here at the Australia studio. Just a reminder to head over to bytes.com or to spacenuts.io and you can sign up for the Astronomy Daily newsletter to get your daily fill of space, science and astronomy news from all over the globe. Los Angeles was once the best place in the world to see the universe. The most important things we know about the cosmos were discovered early in the 20th century at Mount Wilson Observatory. It was there 100 years ago that Edwin Hubble noted a light in the distance that would lead to one of science's greatest discoveries. By night, astronomers kept watch at the best telescopes on Earth, but by day, a city grew between the mountains and the sea. The lights of Los Angeles multiplied with each passing year until their glow obscured that of the stars above. As such, astronomers moved on to clearer skies, beneath which larger and more powerful telescopes would be built, and Mount Wilson Observatory discovered what many aging luminaries in LA have: once your star fades, no one is quite sure what to do with you. With an annual budget smaller than that of some fancy LA parties, a non-profit organisation and volunteers have done a heroic job of keeping the grounds and telescopes open for visitors, and a few scientists still working there. But as the 100th anniversary of Mount Wilson's greatest discovery approaches this week, those most dedicated to the historic and scientific treasure could use a breakthrough of their own. The observatory sits at the summit of 5,715-foot Mount Wilson, accessible only by a serpentine stretch of Angelo's Crest Highway. When George Ellery Hale established it in 1904, building a mountaintop telescope demanded a new level of ambition. Mules and mule-driven carts hauled hundreds of tons of material up the 18-mile road, which wasn't paved until 1907. In 1908, the animals delivered a 16-inch wide 1,900-pound mirror to collect light from the stars, the keystone of the largest and most powerful instrument of its kind in the world. The mirror wasn't even installed before Hale began planning for a 100-inch telescope that would gather 3 times as much light. His philosophy was to go to the best possible place where the air was steady and the skies were dark, build the cutting-edge instruments like had never been built before, and hire the very best people he could to use them, said Hal McAllister, Professor Emeritus of Astronomy at Georgia State University and a former executive director of the Mount Wilson Institute that now manages the observatory. He achieved all 3 of those objectives, he said. Among those hirees was Edwin Hubble, who arrived at the observatory as a staff astronomer in 1919. The kind of temperament that can tolerate long nights alone with the stars often has a lot of room for quirks, and Hubble was no different. He attended Oxford University as a Rhodes Scholar and came home with an affected British accent, and he turned on and off for the rest of his life. Although he told friends and biographers he practiced law and turned to astronomy, he was in fact a high school teacher who never handled a case. Though he sometimes played loose with the facts of his life, he was famously disciplined about the stars. On the night of October 5, 1923, Hubble pointed the 100-inch telescope towards M31, a blob of faint light then known as the Andromeda Nebula. The human eye only collects up to 0.2 seconds of visual data before uploading it to the brain. A camera can collect light over a much longer period, which is why long exposure photographs of the night sky contain far more stars and are visible to the naked eye. Hubble set the telescope's camera to capture a photograph with a 45-minute exposure and developed the result onto a glass plate. Over the following weeks, as Hubble peered closely at the image, he noticed 3 distinct points of light in the fuzzy cloud of stars. Rather than the single one he expected to see, he marked each with an N for nova. He started going through the other plates in the Carnegie Observatory archives in Pasadena to figure out what those extra points of light might be. As he pored carefully through the labelled images, he realised that one light grew brighter and dimmer in regular intervals over the months. It was a Cepheid variable, a type of star beloved by astronomers because its luminosity and pulse length can be used to measure its distance from Earth. At this, even the reticent Hubble allowed himself to celebrate. He went back to the plate, crossed out the N and wrote VAR, V-A-R, in capital letters. Energised by the finding, Hubble carried out the calculations and realised the Cepheid had led him to an even greater discovery. The star was farther away than anything in the Milky Way galaxy, too far, in fact, to still be considered part of it. Andromeda was not another star in our galaxy, but a galaxy all its own. In a flash of light, the universe had become a vaster and more interesting place. Nearly 100 years later, Tom Meneghini executive director of the Mount Wilson Institute, stepped expertly among the vintage scientific equipment scattered around the floor of the great telescope, reaching into the shadows to flick on light switches he knew were there. "All this you see here, all this steel, all this concrete came up by mule," he said, gesturing to the thick lattice work supporting the upper floors and the pile of old telescope track wheels rusting in the corner. A lifelong astronomy enthusiast, Meneghini began volunteering as a Mount Wilson telescope operator in 2002. He took over management of the Institute in 2014 after retiring from Star Harbor Federal Credit Union. He was visiting Mount Wilson with John Mulcahy, a director of the Carnegie Observatories. "This is where the magic happened," Mulcahy said, looking admiringly into the rafters of the massive dome. The office for Carnegie Observatory still occupies its original space in Pasadena, a 1912 building with a book-lined library, a large portrait of Hale, and a photograph of Albert Einstein posing next to the same portrait of Hale in the same book-lined library. The Vary plate still lives there, as do 250,000 others taken over the years at Mount Wilson. Among the other records, the archives contain a copy of Hubble's logbook from the fall of 1923. His handwriting in the October 5 entry is unusually cramped and urgent, the Hubble equivalent of unrestrained glee. Hubble remained on staff at Mount Wilson until his death in 1953 from a blood clot in the brain, yet even in his heyday he could tell that the swiftly multiplying lights at the foot of the mountain would spell trouble for stargazers. In 1934, when Hale was looking for a place to install his 200-inch mirror telescope, he chose Palomar Mountain in San Diego County for its darker skies. In 1969, Carnegie opened Las Campanas Observatory in Chile's Atacama Desert, replete with a 100-inch reflecting telescope of its own. Despite its august place in scientific history, Mount Wilson was no longer the best place on Earth to do astronomy. Carnegie pulled its funding from the observatory and closed the big telescope in June 1985. It's been nearly 40 years since Carnegie Science ran out of money to keep its original observatory open. They also couldn't afford to close it. Carnegie's agreement with the US Forest Service stipulates that the observatory must remain an active site for research, astronomy or education, or be dismantled down to the last historic bolt. Volunteers built modern digital tracking and driving systems to steer the 60 and 100-inch telescopes. They lubricate the telescopes and operate them on public viewing nights. They maintain century-old electrical wiring and repair machinery erected when Woodrow Wilson was the president. Meneghini says, "We're running a lot on free labour. We put out a call for volunteer engineer and we get 10. The only people who have time to do this are retirees," he says, who spend about 60 unpaid hours per week managing personnel, paying bills, and doing any odd jobs that need doing. A self-guided walking tour would teach visitors about the achievements that took place there. By a crumbling concrete wall, Albert A. Michelson conducted an experiment that yielded the most precise measurement of the speed of light available at that time. At the 60-inch telescope, Harrow Shapley discovered that our solar system occupied not the galaxy-hallowed centre, but a nondescript place in its outer suburbs. Hubble's observations at the 100-inch telescope revealed that the universe was not only vast, but expanding. All of this takes money, but to make money you have to have money, McAllister said, and the Institute does not. Those who visit Mount Wilson are often captivated by what they find there. By day there's an utterly peaceful stillness, and on nights, when the telescopes open for public viewing, people line up beneath the gaping maws of the towering domes, awaiting their turn to peer out into the cosmos. "There's a magic about this mountain," said Sam Hale, chairman and CEO of the Institute and a grandson of the observatory's founder. "This is the centre of the greatest revolutions in modern astronomy, and so many people don't even know that this place exists," he said. "Shame on us that we haven't gotten more people here." Carnegie Science is hosting several events around Los Angeles in honour of the Vase Plate's centenary, including the fundraising at its Pasadena building and a public talk with LACMA, but there will be no big event at the observatory. A planned celebration collapsed at the last minute when a contracted organiser backed out. Instead, the Mount Wilson Institute will honour the day as it has every other. by maintaining the place where we found our place in the universe. And there you have it for another episode. Thank you so much for staying with us. I hope you enjoyed that episode. And if you are after some more information about Mount Wilson Observatory, you can go to the website, which is www.mountwilson, that's mtwilson.edu. So thank you for joining us, and our regular reminder that you can find all the episodes of Space Nuts with Andrew Dunkley and Professor Fred Watson, as well as current and back episodes of our podcast, Astronomy Daily with Tim Gibbs from the studio in Bath, England, and yours truly, Steve Dunkley from the Australian studio at this address, spacenuts.io or bitesz.com, that's bitesz or z.com. So head over there and click the links and enjoy your fill of space, science and stuff. But that's not all. While you're there, sign up and receive the Astronomy Daily newsletter. It's an all-you-can-eat buffet of all the news that's orbital, astronomical and way out there. So closer to home, you can also drop into the Space Nuts Facebook group page and say hi. We'd love to hear from you. I know I would. Thanks again for joining us on Astronomy Daily. Bye for now.
Thanks for listening.
Astronomy Daily, the podcast, with your host, Steve Dunkley.